Hello students, today we're doing 6.3 Systems of Equations from Context, which is the same as word problems. Okay, so we are going to be able to create a system of linear equations from real life scenarios, and we're going to be able to solve the system using graphing. So let's hit that out of the park right now. I'm going to be using Desmos. You will not be able to see it on my screen. So if you're following along in this video, please have Desmos open and available, and or just trust me when I get the right answers, okay? But I'm not just pulling numbers out of nowhere. When I'm doing this, I'm getting my numbers from Desmos.com when I get the answers, okay? The entirety of this lesson is really this first learning target, okay? Can we make the equations from stuff that we're given? Okay. When we have a system of equations, well, think back to when we had our word problems before. We had like one thing going on. Okay, now we have more than one thing, which is why we need two equations, a system. Okay. So sorry, this video is going to be a lot of reading. Okay. For our first problem, we're talking about Johnny and Maria working at a dry cleaners, ironing shirts. Johnny can iron 30 shirts per hour and Maria can iron 15 shirts per hour. Johnny worked 2 more hours than Maria, and they ironed 330 shirts between them. Write a system of equations that could be used to determine the number of hours Johnny worked and the number of hours Maria worked. So these are the questions that we have to ask ourselves. So every time I'm doing one of these problems, this is what's going through my head. What am I actually trying to figure out? And what do I know about these people? Okay? So what I'm actually trying to figure out is the number of hours Johnny worked and the number of hours Maria worked. Fun fact, every problem that you do is going to say something like that. Determine the blah, blah, blah. Determine the blah, blah, blah. Okay, and that's what you're always trying to figure out. Delta Math likes to try and give that away to you. Okay, so what is it we're trying to solve in our problem here? Well, we want to figure out how many hours Johnny worked. And the number of hours Maria worked. Okay, we have some constraints. We have some things that we know about these people. Okay, Johnny can iron 30 shirts per hour. Maria, I'm going to put J and M just to keep it short, can iron 15 shirts per hour. And we know that Johnny, worked 2 more hours than Maria. Okay, so we know 3 things. Oh, we actually know 4 things. They ironed 330 shirts total. Okay, so we're going to use the question part of the problem. The question means, like, what is it we're trying to do? Okay, so the part I have bolded and italicized is always the question part. We're going to use that to define our variables. So we're going to say, let's use J still. J for Johnny. J is going to be the number of hours Johnny worked. And M is going to be the number of hours Maria worked. Okay, With the two equations, you will have one equation for each kind of restraint. For example, one equation might be the number of items, while the other is the value or rate of the items. So our items are shirts. Notice in my problem, I had 15 shirts, 30 shirts, 330 shirts. I had 3 things that went along with shirts. That's my item. Okay, so those things are all going to go together. When in doubt, keep like things together. Okay, that's my number of items equation. That's typically the easiest one to find. Okay, so we're going to put our hint over here. Keep like things together. And we're holding to that, okay? 30 shirts is Johnny. So my 30 is gonna go with J. 30 shirts per hour, Johnny's number of hours, plus 15 shirts per hour, and that's Maria's number of hours. And we know that they ironed 330 shirts total. So there we go. I've used 3 pieces of my 4 pieces of information, and I made one of my equations. I am always going to have one piece that's not quite the same, and it's this one. We know that Johnny worked 2 more hours than Maria. So think of it like this. We're going to use some space down here. Okay, if Johnny worked 2 more hours than Maria, I'm going to put Maria and Johnny, then we're dependent on Maria's hours. If she worked 1, we know that Johnny worked 3. If she works 5 hours, we know that Johnny worked 7. So the amount of hours that Johnny works is determined by the amount of hours that Maria works. And we know that he works 2 more than her, which is plus 2. So my value or my rate equation is going to be Maria's hours plus 2 equals Johnny's, because I know that Johnny worked 2 more hours than Maria. Okay? After this, we would graph the system using Desmos or Delta Math. When I plot that, I get the 0.68 as my solution, which means Maria worked 6 hours. And Johnny worked 8, which that makes sense, right? Because we know that he worked 2 more than her. 6 plus 2 is 8. And if you plug in 6 and 8 into my equation, you get 330. Okay. So, let's keep going. A company produces fruity drinks that contain a percentage of real fruit juice. Drink A contains 25% real fruit juice, and drink B contains 20%. The company made 280 liters of fruity drinks with 61 liters of real fruit juice. Write a system of equations that could be used to determine the numbers of liters of drink A and the number of liters of drink B. So, we have A and B, so I'm just going to use A and B. Let A equal, they told me the number of liters of drink A. You don't have to think about this part, okay? It's always going to be write a system, blah, 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 that could be used to determine the and the blah, 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 okay? It's always going to say something like that. After the word determine, that's what you want, okay? And we're going to let B be the number of liters of drink B. Okay. I have three things that to me go together. Yes, we have 280 liters of fruity drink, but I see 25% real fruit juice, 20% real fruit juice, 61 liters real fruit juice. Those are three things that go together. And so that's going to be my number of items equation. Okay. Drink A, so we're going to put 25% with A, except they're not going to want percent, so we're going to change it to a decimal. 25% as a decimal is 0.25 A. So I'm keeping like things together. Drink A has the 25%, so that's what we're going with. Plus 0.20, because that's 20% as the decimal. Drink B, and that combined is 61 liters of real fruit juice in total. Now, my value or rate equation, I know that A is the number of liters of drink A, and B is the number of liters of drink B. If I combine both of them, then I have 280. I have all the liters of all the fruity drinks. Okay, so A being everything we have of drink A, and B being everything we have of drink B, that equals 280. Okay, so A plus B equals 280. Let that sink in for a little bit. This is a little trickier, okay? I'm gonna go a bit faster. Emily and her children went into a grocery store and bought $20.80 worth of bananas and peaches. So there's my things, bananas and peaches. Each banana costs 80 cents and each peach costs $2. She bought a total of 14 bananas and peaches together. Write a system of equations that can be used to determine the number of bananas and the number of peaches. So let's do B for bananas, number of bananas, and P is the number of peaches. Okay, the number of items equation is always easiest for me. I'm going to look over here and I'm going to find my three things. I see money, money, and money, the worth of each item. Okay, so I know that we bought a total of $20.80 of bananas and peaches. As far as banana goes, I know that we bought each banana cost 80 cents, and I know that each peach is $2. Notice I put 0.80 like they did, and I put $2, just plain old 2. Okay. Determine the number of bananas and peaches that Emily bought. Well, here's my number of bananas and here's my number of peaches. Together, that's the amount of bananas and peaches that I bought. So this one is like the one above, just B plus P equals 14, because I know I have 14 bananas and peaches all together. Okay. Last one. We've got nickels and dimes, so let's do N and D. Victoria has $1.90 worth of nickels and dimes. She has 2 more nickels than dimes. Write a system of equation that can be used to determine the number of nickels and the number of dimes. Okay. This one didn't give us a lot of information. That's why I put it on here, because I wanted to talk about, nickels and dimes. Okay. We were only given 2 things, but I know a thing or two about nickels and dimes. I know that a nickel is worth 5 cents. That's 0.05. And I know that a dime is worth 10 cents, which is 0.10. So now I have the worth of a nickel, the worth of a dime, and the worth of both the nickels and the dimes. So I've got my total, and I have 0.05 n, the worth of a nickel times the amount of nickels I have, plus 0.10, the worth of a dime times the amount of dimes that I have. And lastly, I know that I have 2 more nickels than dimes. So I have 2 more nickels. So nickels, dimes. If I have 3 dimes, then I know I have 5 nickels. If I have 10 dimes, I know I have 12 nickels. So I'm going from dimes to nickels, and I'm adding 2 each time. So I know that my equation is going to be d plus 2 equals n. And that is how it's done. Okay? Email me if you have any questions. Thank you.